14. Welcome to my office. My shoe rack behind me. My daughter's map of the world. Yeah. So one thing I'll say when I booked this, I just said 12:15 on a Thursday. Then I checked my calendar. My daughter's got a singing lesson at 12:15 via Zoom. So if you all hear singing from the next room, it's my daughter. I'm in a Zoom singing lesson. So we're all still getting educated by Zoom here in Melbourne. Hello from Berwick. Berwick, Scotland? Is that right? Or Berwick somewhere else? Is there a Berwick in Melbourne? A Berwick in Victoria? Or Berwick upon Tweed? Deakin is missing in this list. Well, hi Bill. Well, you'll have to have a chat with your professor to try and get him to see if he can sponsor us. So we'd love to have more sponsors for all the universities. Right, anyway, so 12:15, how many attendees have we got? How do I figure that out? Jeez. 71 at the moment. So that's not bad for all Brian Hill. Got two. So right, so we'll give everyone a couple of minutes to start, but welcome to Data Science Melbourne and another online webinar that we're going to give with Damian Franco, who hopefully you can all see there. We'll get to Damien and his talk about 2 or 3 minutes when we've given people time to join. So what I'll start with is just saying, yeah, thanks for coming. Thanks for all our sponsors that you can hopefully see on the screen. Without help like that, these events wouldn't go ahead. Well, they probably would at the moment because it's pretty easy doing webinars. But when we have live events, it's quite a lot of organising goes on because we've got such a big group. So we've got over 13,000 members now, one of the biggest in the world. So our events are quite good, quite big. Hope we can see you in the flesh sooner rather than later. So what else can I ramble on about while we wait for people? Yeah, all sponsors are welcome. So what we really not desperate for, but what we really appreciate is if you've got a pretty large venue and you can cater for us, so we can put on events. We like sponsors who can just provide the venue and catering, and we can organise all the talks, because venues is actually a problem for us because it's prohibitively expensive because of the number of people we get to essentially pay for them. Oh, Eric is giving me some tips. Thanks, Eric. There's a setting on your profile to always display meeting controls on your screen. That might be a bit complicated for me to find at the moment, but I'll look at that later. All right. What else have I got for you? Yeah, so Damien got in touch with me just over a month ago. Damien's regular attendee at one of our events, and he says, how would you like a talk? I said, great. So that's how this arrived. So we arrived here. So if anyone has got any interesting talks, or you want to give a webinar, we can arrange it. A couple of rules though: there's no product promotions, no sales pitches. It's got to be generically informative, so people can take some knowledge out and go explore things for themselves without having to have a particular software or software license. So one thing, we're using the question and answers. So Justin's just asked a question: any chance of a webinar on maths and data around epidemics? Yes, if someone wants to volunteer one, we'll see what we can do. Right. Couple of more things. Yeah, we're going to be using the Q&A during this talk. So you should be able to see, we're probably all familiar with Zoom now, you're probably all more familiar than me, but there's a question and answer panel. And during Damien's talk, if you want to if you want to ask him a question, just type it in there, and people can vote for questions they want asked. Now, either me or Damien, we might jump in during the talk and answer them while we're going, or we might just leave them to the end and do questions at the end. We'll see how we go. Now, one more thing. So that's so we've got the chat. There's two windows. There's a Q&A, which will be about Damien's talk, and we've got the chat where you can say hello and just generally chat to everyone. But you've got to select the all panelists and attendees if you want everyone to see it. Okay, so what I'm going to say now is I've had a lot of emails. I got a lot of emails recently from basically students saying, can you help me out trying to find an internship? So I mean, I know everyone's going through a particularly tough time at the minute. There's probably a lot of you looking for jobs, a lot of you looking for internships. It's pretty difficult with the current situation. So yeah, I appreciate you getting in touch, but there's not a lot I can do right from a one-on-one perspective. But what we are trying to do is give you the opportunity to shine by trying to do an online datathon. I don't know if you're all aware of the Melbourne Datathon. It's going to be a bit different this year if it goes ahead because it's going to have to be online. And what we want to do is give students or people searching for opportunities like a shop window, basically, to put themselves out there so companies can come and find them. So what we need for that, what I'm really after is if you're a company and you do have internships that you can offer, just get in touch with me, and we'll try to bundle them up as prizes. And also, we're also really after challenges for the datathon. It's got to be kind of doable online. So basically, we need some ideas, some data. Just get in touch with me, and we'll see what we can do. That's pretty well it, I think. One other thing. I'll go to my next slide. If you are recruiting, we've got a kind of hidden feature in our website, the Meetup website. It's very hidden. You got to search for it. Well, there's a message board. I think if you go to the web version, you can see the slide there. There's a message boards where one's dedicated to people recruiting. So if you are looking for people, just post it there, and it should get emailed then to everyone who's a member of the group if they tick the right email options. And there's another message board. I get a lot of people trying to ask me to promote their own webinars. You can help yourself. There's a section under there to promote your own stuff. But what I will do now, that's pretty well late. I think we are how many people are we up to? I've lost that box. Doesn't matter. Oh, 121. So I think we've got a quorum now. So we're going to start. So what I will do, figure out how to stop sharing my screen. How do I stop sharing, Damien? Stop share. Right. So we're going to go with the main event of the day, which is Damian Franco, who's going to talk to us all about emotions and how we can model emotions during COVID-19. Just a bit of background to Damien. He's a regular attendee of the group. I think he offered to do a talk before when we had a speaker who got laryngitis, right? And about 60 other people volunteered at the same time. So I'm sorry about that. Now you've got your chance. So as I said, Damien came to me a few weeks ago, said I've got to talk, and said, like, let's do it. So Damien's been doing this for about 20 odd years. Yeah, you're a trained statistician and predominantly marketing. But what I'll do, I'll let you introduce yourself, and over to Damien. Thanks a lot.
Brilliant. Thanks, Phil. And yeah, thanks again, everyone, for your time. I'm really excited to be here. Unfortunately, not face to face, but still being able to present some of the proof of concept work I've been conducting since really COVID-19 was first impacting Australia and the world. And today I'll be running through a little bit of the theory of emotions that we work with. some of the basic and more advanced text analytics models, and finally, a few real-world data applications. So as a very quick introduction to me, I studied psychology and computer science over 20 years ago now, and this is kind of how computers looked when I was at university and kind of how psychology looked when I was at university. And really the two were seen as quite separate domains. So computer science was something that was done in a computer lab and psychology something that was done on a couch. We had kind of some emerging sciences like neuropsychology and some initial kinds of AI and those types of things, but all of that research was really pretty much in its infancy. So things have really come a long way in that time. So nowadays, broadly in my role, I'm helping organizations to solve problems by understanding people, their behaviors, wants, needs, and at scale using, computational stats and different algorithms. So my day job is as a marketing scientist, and really that kind of role is merging into a data scientist within a marketing domain. And these are just some of the tools that are typically used day to day. And our typical kind of workflow would start with some data capture, so maybe primary data or connecting to third-party data or any other client data, would then use some ETL tools, either Alteryx or 9, and then use some statistical computing, whether it be R, Sawtooth, or Python, and then into reporting the types of results. And yeah, there's heaps of different ways that you can do that these days. The idea of exploring emotion in social media came from really an interest in wanting to understand people, and given the once in a lifetime opportunity to explore this during a really significant global event, which was COVID, which was happening at the time. And where I work at Colmar Brunton, we've tracked the social values of Australians since 1999, and we theorize that these values are really cyclical and somewhat predictable. And so the insights that we get from these types of studies about society, we use to help clients with a range of business issues and also help to contextualize the results that we give them. When COVID-19 hit, I became very interested in ways of front-running what some of these indicators might be that are going to start to shift society's values. So aside from just because this is interesting to look at, understanding emotions is becoming really more important and will become more important. And this is as our interactions with machines increase and the data that we make available becomes more ubiquitous in society. And so some of the types of applications might be, understanding when a customer service bot needs to escalate someone to a human or to monitor customer reactions for flags. Understanding human emotion is also really important from a marketing perspective. Marketers and advertisers really rely on being able to both manipulate and understand how we're feeling to be able to make products that are more suited to us or make better services available. Also, by modeling emotions, we can start to provide some extra context into just sentiment alone. So using text as a way of analyzing emotions have really got a number of advantages and disadvantages. So there's lots of different ways in which you can detect emotions, and facial coding of emotions has become quite popular these days. So Effectiva is one of the leaders of this, and facial encoding is great for picking up things like surprise, boredom, curiosity, and disgust. Audio can also be used to monitor emotions to really good effect. And there's also a really big range of biometric monitors that measure physiological states too. So things like your galvanic skin responses, those brain caps that you can wear to also monitor things. The real advantage of using text is that it can really convey a bit more complexity about what it is, that emotion that you're feeling about. So that side of things can be missing if you're just passively monitoring someone's facial expressions or galvanic skin response. It's also, text data is more freely available and a lot less intrusive to capture. So you're not relying on having a video of someone or hooking someone up to a machine. So there's a really wide body of research exploring emotions in psychology, and there's lots of different theories. And that's something that's been explored for hundreds of years. But Plutchik is one of the ones that is really well established in the literature, in marketing, and in the data science world. And the model consists of 8 key emotions that are linked to human survival. So joy and sadness, acceptance and disgust, anger and fear, and surprise and anticipation. Once I began through the initial modeling process, it started to become really evident that some emotions were more definitive to identify and to a degree less dependent on things like our learned social norms. And so it started to become really appealing to strip down that model from the 8 different dimensions to something a bit more simplified. And also to link these to some harder physiological human responses. So the initial modeling showed that anger and fear were really the most easily identified by the algorithms. They were less ambiguous emotion, and they're also really rooted in the sympathetic nervous system. Joy and sadness was also really readily identifiable in the modeling, and these emotions are also physiologically linked to our emotional responses. So these emotions are hormonal responses, and they're to do with the neurotransmitters dopamine and serotonin. And so by using this stripped down model, we can kind of simplify our modeling tasks, but still start to retain an effective model to be able to explore some of these ideas with. Some of the emotions in Plutchik's theory that he identifies are a bit more complex. So guilt and shame, disgust and boredom, these are types of emotions that can be probably easily picked up in facial recognition tasks, but actually what's happening below the surface is a bit more complex and is relying on psychological constructs that are more personal rather than generalizable. So they become difficult to embed into a general model that's going to work across a lot of different things. So once I started to get a grasp on the theory and what I was wanting to look at, I went in search of a data set, and the ICEA data set is one of these data sets that is now quite established, and it's used often for the classification of emotional responses. So ICEA stands for the International Survey on Emotion and Antecedents and Reactions. And what it does is it provides a corpus of English descriptions linked to emotional events. So here's just a few examples of the text and the classifications from our for target emotions. So my father gave me money to my brother, but not to me. That invoked some sense of sadness. When my father's new fiance treats me like a child is anger. Being together with my best friend was more a sense of joy. And in the traffic with a car, I nearly got crushed between a bus and a tram is fear, related to fear. And that's a very Melbourne kind of fear as well. So I quite enjoyed seeing that. So the modeling I conducted started with some basic classic style text mining strategies through to some more contemporary techniques, and finally some more advanced strategies for understanding language processing. The execution of classic text mining models works much the same as any other data science model development. So it involves our training set ICEA split into partitions and then just trained and assessed. The classic text mining process involves the cleaning up of sentences, removal of numbers, stop words, and word stemming. This creates a document vector that each word in the corpus is present or not, and so each document or statement from ICEA is tagged with whether or not a word is present or not. The models, the initial models that I was running were quite simplistic, so a single decision tree and a single vector machine, and they kind of had limited accuracy, and I thought that was mostly to do with the fact that one word can only be associated with one coefficient, one modeling coefficient. But when we started to look at random forests that's employing an ensemble of trees, we're able to have words and combinations of words with different coefficients. So we're able to get a little bit more granularity in terms of what words mean. So using the random forest method gave us some really great results. And it did quite a good job of indicating which posts were related to expressions of which emotions. And one of the really interesting ones that I picked up was this one that read, you know, what the F are people doing at Bunnings? And which, you know, to be fair, the model probably accurately predicts that this is anger. But again, I began to get concerned because ICEA doesn't contain the F word, which is probably a word that gets used quite a bit in real world types of applications. But by using this method, our models are only going to be as good as the words that we've trained them on. And to make matters a bit worse, the F word can also be used in many different ways and contexts. So in the joy context, you know, you could be saying, you know, this is so effing good. In a fear context, you could be saying, no way, I'm not effing going outside. So in other words, we have an effing problem. And that was something that I started to get a bit concerned about. So I decided to speak to an expert, and Ryan Stewart is the guy whose NLP is his day job, and he is the founder of Capiche. And he mentioned to me the work that Google and Facebook and others have been doing in the NLP space, and really in particular, sentence processing and neural network-based techniques for natural language processing and NLP pre-training. So after a bit of research, the framework I decided to work with was TensorFlow 2 and Google's Bert. And Bert stands for Biodirectional Encoder Representations from Transformers. And what Bert attempts to do is to understand the words in the context of a sentence. And it does this by pre-learning language from an unsupervised learning corpus. So in Bert's case, it was trained on all the textual data in Wikipedia and other open source literature corpuses. So in other words, Bert is a pre-trained neural network that has the understanding of how we use language based off Wikipedia and other data sources. So to understand a bit more about what this means, we need to kind of jump a little bit into the English language and really consider these two sentences as an example. So we have, the animal didn't cross the street because it was too tired, and the animal didn't cross the street because it was too wide. And you can start to see some of the difficulties with dealing with language here. So it can have two different meanings in this example. So it can have the meaning given to it before it appears. So in the first instance, we're talking about it being the animal. And in the second example, we have the meaning of it becoming after it has been placed in the sentence. So we have it meaning it being too wide. And so rather than some of the algorithms that will read a sentence one by one, Bert attempts to consider the full context of the word by looking at the words that are coming before and after it. And this is the biodirectional part of Bert. So computers don't really understand words. They're really better at understanding numbers and vectors. And so to get around this, we have transformers. And transformers attempt to transform words into vectors, where similar words have similar numbers in an embedding space. And so we can see here that we might have some animals that are kind of grouped together, and some fruits and some modes of transport that have some linkage in terms of their meaning. And this is derived from looking at open source data. And so this is how Bert is able to understand these words, and that's the meaning of the T, the transformer in Bert. So this is kind of practically how the data looks. So the sentence will be broken up into its components, so a start and end and the individual words. And each of these individual words are assigned a token ID, and Bert is able to understand what the meaning behind these token IDs. So we can see some of our SEER statements being converted into our token IDs. So developing a model using Bert really follows a similar process again. However, we're starting off with a pre-trained model that understands language, which is really great. And we then take that already pre-trained network and we fine tune that to make predictions. We can then use TensorFlow 2 to execute these models. So in terms of our confusion matrix, we get some really stronger results. So the accuracy that we were getting from joy has now jumped to 93, sadness 87, anger 79, and fear 91. So I became really excited and happy to start to see some of these results. So
sorry, Damien, can I just ask a question there? You go back a slide.
Yeah.
So can you just clarify a bit how you go from the Bert model? What do you do with the outputs of Bert to then feed into your emotion model? Is it just the tokens? Yeah.
Yeah, that's the tokens.
Right. So Bert's kind of a pre-processor essentially.
Yeah, so Bert is the thing that Google has trained to understand a bit about language, and it's done that by basically running unsupervised learning on Wikipedia. Right. And Bert is being employed on your Google searches. And so Google is actually using Bert to help really refine and understand what you're typing when you're typing a query into Google.
Yeah.
And it's also used in their Google Translate. So it's quite a powerful network that's deployed across quite a few different Google services.
If I can, tell me if I'm correct then. So you feed a tweet into Bert. Bert spits out what it thinks you mean is in the sense of these token IDs, and then you train those token IDs on your emotion. That's basically it, right? Awesome.
Yeah. And really, we get a really nice uplift with that in terms of accuracy, because we're starting to able to understand really this the bidirectionality of how words and the meaning of words within a sentence. So we're able to get a really strong uplift. And we can start to see just the graphs on the top. We can see the probabilities really being sharpened up in the case of joy. And we can also look at some of the results of the ICEA training. So some of these statements, and we can have a look at the probability. So when I passed the first examination that I had to repeat, that was detected as a high probability of joy. After my girlfriend had taken her exam, we went to her parents' place, was, you know, a higher probability of joy, but not necessarily. And the lowest probability of joy was when somebody stole my bike. So we can start to understand a bit of the mechanics and how well it's performing. There was some statements in ICEA that I couldn't really understand what the emotion was. So I kind of, I don't blame the model in this case for getting that wrong, because I don't understand what that means.
So sorry, Damien, these are your random forest models now, are they?
These are what's coming from Bert.
Sorry, so I thought you then fed Bert into your own, I thought you used the outputs of Bert to then build a model with your target emotion. So this is...
Yeah. So this is the outputs of those models.
Right. So those models aren't then your random forest, your decision trees, support vector machine. These are coming straight out of Bert.
Yeah, I kind of skipped that part for time.
Right. Okay.
So yeah, well, by the time I got to this point, I was, you know, pretty encouraged about some of the results that I was seeing. So I decided that I would start to test it on some real world data. And so I decided that I'd pull, using the Twitter API, 10,000 tweets with hashtag Melbourne. And then I analyzed the models with the tweets with the models. And I then used Tableau Public to display and share the results. And yeah, if you log on to that, you can see the actual all of the actual individual tweets and classifications. Really, my first observation when I analyzed all these tweets was that the balance between joy and sadness was quite large. So joy was 3%, sadness 10%, and people were mostly angry rather than fearful. And so this is all tweets from last weekend. So you need to just think back to what was happening last weekend.
Sorry, David, I think we've got one question. How many tweets were there altogether?
10,000.
10,000, okay.
Yeah.
Right.
So we can start to see some of the kind of the classifications here of all of those tweets and explore the model on these dimensions. So the dimensions that we put them on were the joy and sadness and the fear and anger.
Did you actually analyze so you're saying 72% of tweets had no emotion. Did you have a look at those that were classified as nothing to kind of see what they were about? Or?
Yes. So some were quite informative. So things that were talking about the weather and that sort of thing.
Yeah.
Others, I guess, perhaps you could say that there wasn't enough information in our training to have picked up certain things. So ICEA is a bit limited in that, the statements are a little clunky. That's why actually I was quite surprised that by looking at the types of statements that were in ICEA, that we're actually able to do such a good job with, classifying the emotions. So if you wanted to, I guess, improve that 72%, you would perhaps start to look at improving the quality of your training set.
Yeah. So I think we've got a question here that I think your chart there probably gives us the answer. It says, does it tell how strong the emotions are? A model? That's the probability essentially, right?
Yeah, so the probability, so if we take a look at, this, we can see the probability of joy. And, where you cut off the points at these models with real world tweets, probably needs to get adjusted to what starts to logically make sense. So the balance of what the models are really interpreting as right and what you think are, starting to get a little sketchy. And the process of accuracy of emotional coding is like vague at best because the topic of emotion, but I've kind of had a go at kind of just, glancing through some of these things. And yeah, given that, really limited training set, I don't think it's actually done too bad a job. There's, fun and weird quirks like the normal NLP problems with irony. I'm not, that's, always going to be a feature. There's things like enjoy your day being a sentence at the end of a weather report, which is, I guess, is that joy? Well, it's also attached to an informative statement. And you've got things like, Melbourne to win, which, would be joyous, but it's in the context of someone making a punt. So there is quirks, but there's also, some reasonable kind of estimations on that.
So what about emojis? Do they get fed into Bert? If you put a smiley face on, would he say I'm happy? Or?
I did want to check. I did want to check what has been and hasn't been in Bert because it's based off Wikipedia, and I haven't seen many smiley faces in Wikipedia, so maybe it doesn't have that. So you would probably, what you would do is you would probably include an addendum to your training set that had all of those emojis in them and what to code those. So you could bulk out ASCII to include those types of quirks too. But also, if you had a specific application like sports betting or something like that, you would probably want to build your own corpus and training set anyway, because some of your customers might be using some quite specific language. So after running the 10,000 odd Melbourne tweets, I decided it would be really interesting to see how Melbourne was going to be comparing to other cities on the same day. So again, this is last weekend, so you need to, I guess, try to think in the context of what was happening in some of these cities last weekend. But what I did was took the same amount, so 10,000 tweets from each of these other cities on the slides. And so I guess you can start to hypothesize around some cultural differences. So maybe the British being a little bit polite and not necessarily showing so much anger or indeed any emotion as well. Phil, you might.
You've obviously never been to Oldham.
No, well, this is just London, so yeah, you don't see that many smiles getting around London often. So I guess some of the points, yeah, you could probably adjust for some of these cultural differences or how language is being used in different cities possibly, but I really wanted to run it with the same algorithm to see what those differences were, and if we could start to see if there's differences in between the cities due to the impact of the pandemic and, you know, other cities facing lockdown as well. And so you can see that Melbourne has, you know, by far the lowest joy in Australian cities, which is we were the only city in lockdown. But, you know, thankfully we're not living in LA that has even kind of less things to be happy about and a much higher fear. I'm not sure if that's a regular fear that's experienced in LA. Having visited there, it can be a scary place. And in fact, LA and Auckland have the same amount of fear. And if you think back to last weekend, really the big news in Auckland was about the detection of new COVID cases. So you had the city kind of freaking out about these half a dozen cases and that COVID was going to be there again. So that was interesting that we're detecting that kind of fear spike. New York City had both the highest anger and sadness, which I'd kind of expect kind of anger and a bit of high strung in New Yorkers. The sadness was, you know, pretty amazing there. And, you know, what's happening in New York at the moment is they're also having lockdown and curfew, and they've got places like Fifth Avenue completely boarded up. So, yeah, it was interesting to see that we're able to see some really good differences between being detected in some of these things.
One question, well, I'm thinking, what do you do with retweets? Is a retweet kind of a duplicate of the same tweet, or is that filtered out?
Yeah, so I thought that it was fair to keep retweets in because as Twitter samples up, I figured that it was going to take that random sample, and if that tweet is being propagated within, you know, that city's corpus, then it's fair to say that that's part of, I guess, the emotional load of the city. So you might be also thinking about if we can look at non-English speaking cities with Bert, and really amazingly we can without any need for pre-translation. So when I started to look at the tweets of the different cities, we found Spanish, Chinese, and Japanese tweets, and they were getting classified accordingly. So that was really exciting to see. And so I looked a bit further into it because it wasn't something that I was actually thinking about at the time. I looked further into it, and Bert is pre-trained on about 40 different languages, and certainly the main kind of languages. So that was a really neat feature that I wasn't even expecting. So I guess my key learning out of all of this exercise was that you needed to have really a full context of how words are being used within a sentence to really successfully make predictions of what emotions might be conveyed in a tweet. And as you know, those predictions are only going to be as good as your training set, so you have to always keep that in mind. And when you do start to make predictions on real world applications, there's possibly going to be need for calibrations and that sort of thing. So I've included some links in the presentation for ICEA, Google, and Bert. And so ICEA is actually hosted on Kaggle as well. So that must have been used in some competitions. So wrapping up, I think it's really possible with some degree of accuracy at least to code and track emotions in consumer conversations. And I think it opens up some really interesting layers of additional insight into social media monitoring. Looking at emotions potentially gives us more useful understanding of what's happening rather than just sentiment alone. And so, yeah, this will be something that I'm going to be further researching. So please follow me on LinkedIn or reach out if you've got any questions. So,
all right, thank you very much, Tim. We have a few questions. So we've got 23 open questions. So we've got about 10 minutes left. So we'll go through. You can see the questions there, right? So
hang on.
I can read them out for you if you want.
Read them out. Hopefully they're not how transformers work. There's a link. There's a link for that someone can explain it far better than me.
So the second most popular question for show. The slides will be available afterwards, right? So you're gonna. What I suggested, Damien will put them somewhere where he can control them, and we'll post a link in this event page on our meetup group, or Damien will post a link to his slides. That's the easiest way to do it. So that's that one. So the answer to that will be yes. And also we're recording it as well. So at some point when we get around to it, there might be a video on YouTube, if that's okay with Damien. That might not be immediately. Right, so Adrian's got a good question. Tell us about people in hoard toilet rolls. What are they? Are they angry?
Well, so that was part of the interest in it, because I wanted to understand if you could predict that type of behavior. Yeah. And reflecting on what was happening in Auckland at the time, if you've got a fear of 18 happening in the city, people are going to be in supermarkets hoarding dunny paper, and I guess maybe in LA they're possibly reflecting or behaving slightly differently.
Well, actually, someone did mention that in LA last week there were the bushfires as well.
Yeah, exactly, and some fire tornadoes and all sorts of crazy stuff.
So there might be not necessarily a COVID thing. They just frightened the house might burn down, I guess. yeah, can you please share the recording of materials for attendees to learn? Yeah, so we'll do that. So as I said, for the when Damien gets around to it, maybe today or tomorrow, we'll post a link. Go to this event meetup link, and in the kind of discussion section, he'll post a link. And when the video is available, we'll put the link there as well. So you just have to go back to this event page. What else have we got? What are the controls to ensure the sentence is grammatically correct? And does the model identify issues with grammar, which may impact the accurate identification of sentiment? That's probably the fourth question down.
Yeah, so I guess that would be if you can imagine some of the interesting things that people are typing into Google, and Google's still able to kind of interpret some of those key meanings and key kind of things. I think you can kind of get a bit of a picture of that. I will just try to. Can you see the Tableau coming up there?
Yep. Is this Tableau online? This Tableau Public's available for everyone, right?
Yeah, this is available. I can post the link to this as well.
Yeah, cool.
So I guess this one here, you know, beautiful Melbourne. You know, we've classified that as joy, which isn't, you know, this could be beautiful Melbourne with some sort of image that I haven't picked up, but it's not something that's, you know, particularly complete, but it's picked up enough of something in there to classify something. And there's, of course, within all of this stuff, there's going to be a certain amount of error, of course, in all of it. And what I hope is that by grabbing a really big bunch, so 10,000, that some of that error and vagary is kind of washed out a little bit.
Okay, so you've posted the someone's posted the link.
Yeah.
In the Q&A. So does Shant ask, are emotions conveyed differently in different languages? If so, what will that affect the word vectors created by Bert, assuming it is only trained? Well, I think you've answered that. It's not only trained on English corpus, it's trained on all languages.
Yeah, and like I said, there could be some, you know, cultural adjustments that you might make. So when I was looking at some of the results at an individual level for, say, London, I kind of recognized that they were potentially being a lot more polite about certain topics than what New Yorkers were being. So there could be, you know, some calibration in terms of where in a city where someone's from or what language they're speaking, those types of things, because emotion is a bit nebulous in terms of, you know, because you're talking about, you know, feelings and how a person's feeling. You could look at kind of some of those calibrations, but you'd have to do a lot more kind of research into that.
I've got a question. So if someone's never done text mining or this kind of stuff before, and they wanted to replicate essentially what you've done, to me, there's this big fear factor. Well, there's a big fear. There's a, what's it called? It's fear factor of how on earth do I do that? Should I even attempt? I mean, can you talk us through, you know, what's the work involved? is it that difficult? I mean, you just, you're using pre-built libraries, but should people attempt it, and what do you think? How successful they think they'll be if they've never done it before?
Well, it's the question, how do you eat an elephant? And the answer is it's one mouthful at a time. So
yeah, exactly, yeah.
You really need to start off. Like, I know that this group online today is a really diverse group. So you've got people that are going to know a heck of a lot more about neural network modeling than myself, that hopefully has a bit of information on, emotions to go off and tinker with bits and pieces. You might have people that can understand some more simplistic sort of modeling, like single vector machines or random forests, that might want to start in at that point and elevate into, more sophisticated areas of NLP. If you're starting from zero, I definitely recommend starting at very much the very start of kind of text mining and the basics of text mining. So I already had an understanding of that. So I was able to kind of move through from a middle point rather than a start point for this exercise.
About a lot of these, like the Bert things, Google have done a lot of the work already, haven't they? So it's not as if you're building it from the ground up and coding every single line of code. There's a lot of reusable stuff there.
It's exactly, and the amazing thing is that there's a lot of YouTube, there's Jupyter books, and other blogs available that kind of step through how to do some of this stuff. But certainly understanding kind of the basic mechanics of text, and yeah, that's important to at least understand a little bit about first.
Oh, thanks, Dave. That was a pretty awesome talk. Thanks for volunteering and sticking your hand up, and I think it went really well. I think we're just about out of time, so thank you very much, and thanks to our audience for joining us. And we've got a few more webinars coming up, so just keep an eye on our Data Science Melbourne meetup group. Felipe is doing a few for Data Futurology beginning of next month. Melbourne University have got one coming up, and in about a month, yours truly will be giving a talk, which will be really good, I promise. Okay, right. Many thanks, and we'll leave it there and see you later. Thanks, Damien.
Thank you. Bye for now.
Bye, everyone.